Okay, right now we're going to talk about electromagnetic waves. And the definition of an electromagnetic wave is a combination of fields that are electrical and also magnetic. These fields are all perpendicular to each other. Like many topics of physics, this is hard to actually picture, but it does share the same traits as some of the waves we see in everyday life. The form of the wave is similar to the forms of other types of wave. Some types of electromagnetic waves include radio waves, microwave, X-rays, and even light. However, the effect that waves have on matter all depend on where it lands in the electromagnetic spectrum. Some properties of electromagnetic waves include that it does not need a medium to travel through, such as sound. An electromagnetic wave has no mass, but it does carry different types and forms of energy. It also contains momentum and has the ability to exert pressure on other objects. The reason tails of comets point away from the sun is the radiation pressure exerted on the tail by the light and other forms of radiation from the sun. Now we'll talk about how an electromagnetic wave is produced. To produce an electromagnetic wave, a charged particle produces an electric field. This electric field exerts a force on the charged particles. Positive charges accelerate in the direction of the field, and negative charges accelerate in the direction opposite of the direction of the field. Also, a moving charged particle produces a magnetic field. This field exerts a force on the other moving charges. The force on those charges is always perpendicular to the direction of their velocity, and therefore only charges in the direction of the velocity. Since electromagnetic waves are electric and magnetic field traveling through empty space at the speed of light, then an electric charged particle produces an electric magnetic wave. So essentially, the essential part of creating an electromagnetic wave is the charged particles. We know that the moving charges produce magnetic fields, but a constant current produces a constant magnetic field, while a changing current produces a changing field, so they correlate directly with each other. It can go either way as long as there's a current that's being produced, and as long as it's being charged. That is what electromagnetic frequency is all about. A steadily changing magnetic field can induce a constant voltage, but an oscillating magnetic field can induce an oscillating voltage, so those are also related.